Hi, I'm Dave Nelson from Lawrence Livermore National Laboratory, and behind me is the Mirror Fusion Test Facility, currently under construction. As you can see, it's a rather large experiment. The building itself is about as long as a football field and maybe 7 stories tall. It's also a rather complex experiment. There's some 20-some neutral beams, about 22 superconducting magnets, some of them are the largest in the world, and all the assorted paraphernalia necessary to control them, such as cryogenics and vacuum system and all that. And we'll be monitoring about 40,000 data points and controlling about 10,000 control points during the experimental operation. The environment is also a rather hostile one. In addition to all of the neutrons and everything, there's about 250 megawatts of power for up to 30 seconds, each 5 minutes, 16 hours a day. Since the environment is so hostile, we have to control the experiment remotely. And so we have a control room about 50 yards away to the north. So let's go take a look at it. A part of the charter of MFTF is to explore alternatives in control room design. Exactly how can we make controlling an experiment this large and complex easier and more reliable? We think we've come up with some rather innovative solutions here in that the operators control the experiment entirely through computer graphics and touch-based systems. Okay? Each operator controls his part of the experiment through one of the consoles that you see in front of you here. Each console is connected to a separate host mainframe, and this console serves as the communications link between the operator and the experimental apparatus. In fact, all communication between the operator and the computers controlling the experiment occurs through these consoles. Now, we control MFTF through a 2-level hierarchy of computer control systems. A local network of 9 mainframe computers provides the supervisory control we need, and connected to this network is a network of some 80 microprocessors. It's these microprocessors that provide the real-time control and monitoring. Now, each hardware component in our system has its designated backup, so no single-point hardware failure can cause any significant downtime. In fact, we must be able to recover from any single-point failure within 5 minutes, and we found that we can do so. So let's see what one of these consoles looks like. First of all, there are the obvious physical characteristics. You have 6 screens here for viewing displays, and 2 screens down here for doing control. The screens down here are covered with a touch-sensitive surface that allows the operator to actually touch the screen and point out a button that he wants to push. Okay? In addition to that, you have some hard buttons up here for doing some of the things that you don't normally do, like stop a shot, log out, stuff like that. Okay? There's a badge reader here, and we'll talk a little bit about the badge reader in just a minute. As far as the less obvious things go, the ergonomics of this console were very carefully thought out. There's room underneath here for knees and for leg room. There's a workbench here, so you can put down your reports or your procedures, whatever you have. The touch panels are very, very easy to reach. You don't have to go out and lean over and reach things that are far away like you do in normal control rooms. The lighting up above is adjustable. Each particular console has its own individual adjustable lighting, and it's easy to maintain. Not only can you maintain the electronics and in here, but you can also maintain the entire screen. Everything pulls out and can be replaced. Okay? It's important to note that all consoles are functionally equivalent. Okay? I can do the same thing here that I can do at any other console in the control room. So what actually makes the consoles different? It's the operator's access rights. Before an operator can control a console, he has to log in with his badge. Goes over, logs in, and by doing that, the software knows exactly who is at this console, okay, and configures the console especially for him. If I'm a vacuum operator, I can't control the neutral beams, and if I'm a neutral beam operator, I can't control the vacuum. If I'm the system supervisor, well, then I can control everything, and if I'm me, I can't control anything. Okay?